Good morning. It is January 3rd. Happy New Year's. Haven't done a video in a while. I was actually trying to complete a video that I started probably 2 months ago. So I added 4 more 100-watt panels, but as you can see, they look a little different than the other 12. Same brand, ordered from the same place. They have a slightly different model number, and I didn't realize that until I got them. Since I added them, I've been waiting, for a nice bright sunny day, and it's not full sun today, but we've had a couple full sun days. Weather's kind of been crap lately. We've been hanging around that 20 to 40 degree area where it's just gray every single day. It's finally kind of cold enough today that you see a little bit of blue sky and the sun's poking out, but even on the days where the sun has been out, I haven't seen my array go up over 1350 watts, and with 1600 watts in panels, that's kind of upsetting, because before the addition of the 4 more panels, I saw my 12 go up over 1200 watts like lots of times. They commonly go about 10% over rated power, so I expected to see all of 1600 watts. I was hopeful to see more. So today we're going to do a little bit of optimization. I've got these wired in series parallel the middle 4 are series together, these 4 are series together, those 4 are series together, and then the new ones I ran a string, a series across, because they're not exactly the same thing. So I was worried that if I just paired the 2 new ones to the 2 old ones, that it might offset balance. So I seriesed the new ones together and then paralleled them together with the old string going in, and this is the wire going in, so that comes up to here. So all 4 series of 4 panels meet right here, and it's not beautiful, but they are all soldered together. But I have a feeling that this connection is probably my weakest link, because everything else is MC4 connections, and that all should be good. So unless I tear this apart and test each panel one at a time, which wouldn't be a bad idea, make sure that they're all putting out similar voltages, but I have a feeling this is my weakest link here. And when I undid the I coated it with a liquid electrical tape. When I undid that and tied in the new ones, I probably should have just cut all the wires, stripped new chunks of wire, and soldered new chunks of wire together, because I just I heated it up and added the two new wires in, and then, you know, globbed some solder on there, and burned it in with the torch. And I have a feeling maybe I compromised that connection. Maybe I burned the wires too much, because that is absolutely a thing. You can burn your conductor and it loses its conductive properties. You throw copper wire in a fire and it breaks down. It loses its conductive properties. So I think I want to take this all apart, cut, you know, a few inches off of each wire, and strip a new chunk and crimp copper ring connectors on there, and then have a bus bar mounted on this pole, tie everything to a bus bar, and link my wire going in to that bus bar. This is 6 gauge? Yeah, 6 gauge stranded copper going in. So there's you know, the wire going in is plenty heavy duty to handle the amps coming in and the volts coming in. The 6 gauge should have absolutely no problem carrying 1600 watts. I should be able to carry 4,000 watts on 6 gauge stranded copper. It's rated for way more than that. And it's only a 30-foot chunk, you know. It's buried 1 foot underground and run right to that window, and that's where my power wall is. So it's not like I'm losing much to you know, over. There shouldn't be any considerable voltage drop getting the power there. Like I said, before I added them, I was getting full power out of the original 12 panels. So I should be seeing, you know, at least 1,500 watts, and I haven't seen the meter go up over 1,350, which is disappointing. I should be getting more than 150 watts out of 4 additional 100-watt panels. Fortunately, Turbine has been moving and making some power. I'm also going to be doing some optimizing downstairs, so let's go check that out. Alrighty, so here is my newer batteries. That's my original battery bank from 5-6 years ago. I've been running on those guys for a long time, but you can see the way they're wired is a series parallel and then piggybacked, and then there's 2 leads that go up to the bus bars and tie into the whole system. This is the correct way to wire up a battery bank. You know, these are 6-volt batteries, so I've got my 2 strings of 24 volts, and then to run into the battery, I've got equal length leads running parallel that go to the bus bars, instead of having it all piggybacked like this. Your batteries on the outside are working harder, and the batteries on the inside are kind of just sitting there. Like if I opened up all the caps, the water on the outside batteries evaporates faster, because they're taking the bulk of the charge, and then they're when there's loads being drawn, they're the ones that are being used. So I want to do the same thing that I have going here, with equal length wires coming off of each pair of batteries, you know, each 24-volt string, and then they'll all meet together. I've got these guys. I haven't decided where they're gonna go. You know, they might have to end up on the wall or something like that, wherever we can get equal length. I'd like to make the same length as these. I'll take one of these off, measure it, and we'll make 4 more red and 4 more black leads. Same length, same gauge. This is 2 gauge, I believe. What do we got? Yep, 2 gauge. So we'll make 4 more of those and have them all pair together. So we'll have equal length wires, and that will evenly divide the load amongst each string of 24 volts. You know, so that's 24 volts, that's 24 volts, that's 24 volts, and so on and so on. We'll pair all those up to a bus bar and then have a main lead go up to the main system. You know, I made this bus bar years back just out of some steel and some hardware and a cutting board. That's a cutting board. So I'm going to do a little bit of reorganizing of stuff and try to simplify some of this wiring, get some of these leads shorter that can, and just, you know, that it's just simple optimization. The system is only as good as its weakest link, so shortening the wires to reduce voltage drop, shortening, and then evening everything out so load and charge is distributed evenly. Right now, these are by far taking the brunt of the load because they have the shortest leads and they're wired correctly. Excuse me. I just refilled the batteries last night. They were an inch low, the fluid. Just topped them off last night and then ran the generator for a little bit to get volts up to 30, so they bubbled and mixed the new distilled water in. So, you know, just simulated an equalization cycle. But these I haven't had to top off in like a year. So they're sitting there and they're tied into the system. They are capacity, but they're not being utilized properly. When I have all this redone with equal length wires, it will be a real 1000 amp hours. Right now, I'm basically only really using that as capacity. You know, this is kind of reserve capacity. So, but it's unbalanced power. So as these guys start to drain, they're drawing power off of those, and you know, it just having everything balanced with electricity, you get push-pull effects. You know, my solar panels are out of balance right now because there's a bad connection in there, and I'm having issues with, you know, batteries almost consistently being low. Yeah, it's been gray outside, so I'm not making good power every day, but I've got a lot of capacity here, and I shouldn't be having the problems I'm having. So we're gonna tear this all apart inside and outside and clean up connections, and I'm gonna try and race the sun. It's about 10:40 right now. I'm gonna try and get all this done before like 2 o'clock while I still have some good sun. So when I flip the switch and let the power come back in, hopefully I can see some results today, because the forecast looks like shit for the rest of the week. And then I won't really know if my work did anything if I don't beat the sun. So I'm gonna quit yapping and I'm gonna get to work, and I will check back when I've got something good to show you. Alright. Okay. Did a little bit of running around, got some materials. This is what I came up with. So instead of this soldered connection, where everything is literally just twisted together, and I gobbed a bunch of solder on there, I do think that is where my problem is. I'm going to cut all these back. I've got my master switch. I've got a disconnect on the end of this wire. That's the wire going into the house. Before the charge controller, there's a master disconnect that is switched off, so there won't be any surging while I'm disconnecting and connecting wires. My idea here is I'm going to mount this box right around here, drill 2 holes in it, one for negative, one for positive, run all the leads in. I've got rubber grommets. I'll drill like a 3/4 inch hole, run the wires all in, crimp copper connectors on all of them, and then I will, on each side, I will run this, 1 bolt into each side, and that will be the lugs that these all stack up on, and then tighten them down. That will be my bus bar. 1 for negative, 1 for positive. And then I also, where I paired, oh here it is, where I paired the 2 new panels together, I just used a yellow butt connector. That's for 10 gauge, but they're kind of, it's real chintzy tin inside of them. So again, you can never say it too many times. The system is only as good as its weakest connection. This could be my problem right here, is just, where these 4 panels are series together. This is the link between those 2 and those 2 new ones. I'm gonna chop that off, strip 2 new pieces of wire, and instead of that, I've got just a piece of, this is 1/4 inch copper tubing, and I cut about an inch long chunk and use the chamfer bit to bore it out a little bit, because the cutter sort of crimps it a little bit, and I'll crimp that down real tight, and then slide some heat shrink over that, and that will be a better connection. Just eliminating all of the possibly questionable connections is just going to make this thing run better. I sit here laying in bed thinking about questionable connections, and it's been cold and crappy out, so I've kind of put it off. I was really just hoping when the sun came out on a nice bright sunny day, which we don't get many of, see the clouds have already come over, that I would see it go up to 15 100, 1600 watts, and that just hasn't been the case. I realize these are a little bit different panels. We can read the model number NPA 100-12H. Well, if we look at one of the older ones, NPA 100-12. So, but the specs are the same, you know, 21.64. Oh, that's open circuit. Yeah, max volts. I can't see this very good. You probably got a better angle. I'm crouching down, but yeah, 17.68 volts, 5.66 amps. What does this guy say? 17 volts, 5.89 amps. It's close, but it's not exactly the same, so it's not perfectly balanced. The first 12 are all the exact same panel. I ordered them all at the same time. I was disappointed, to say the least, that they advertised it as the same thing and they sent something different. They're smaller, but they're still, there's no way that they're only making, you know, whatever. I'm seeing an additional 150 watts, so, you know, divide that by 4. There's no way they're only making, you know, 37.5 watts each. They're at least 80 watt panels, so I should be seeing 1500 watts. Anyways, I'm gonna get to work here. I got some screwing around to do. That's my plan. I'll check back when this is all done and let you check it out. Alrighty, so I got my copper sleeve on this connection. That's the series for the 4 new panels, and I had to change plans a little bit because all 5 wires wouldn't fit through each hole. So I did get the junction box on. They are all crimped and heat shrinked, and then cranked down absolutely as tight as I could get on the lugs. So, you know, now I know definitively they've all got good connections. So this, you know, any question of quality of connections is now taken out of the equation. So if I'm still, you know, no, it's cloudy, so today I'm not going to see full power. I'll probably have to wait a couple of days to complete this video, unfortunately, because I really want to show these things making full power. They should be able to do it. I'm really hoping that new power used perhaps higher efficiency cells. I think these ones were like 18% efficient, and I know they're making cells that are, you know, 20, 22, 26% efficient. So I'm really hoping that they use higher efficiency cells, and that is how they're calling this a 100 watt panel, even though it's, you know, considerably smaller. I think they're not only, you know, like total square foot, they're considerably smaller. But I want to know what is actually capable of coming in. If they're not 100 watt panels, then I want to know what the heck they are. So when we get a day, where I'm home and we got full sun, I will be able to finally wrap this video up. But now it's time to reconnect them, and I don't know, we'll see what's coming in. And then now it's time to play with the batteries. So moving on. Okay, so looks a little different now, eh? The only good way to make this happen with equal length cables was to get these guys raised up to the same level as those. That table wouldn't accommodate for all of them, so I modified this table with some plywood and some 2x8 to be able to support the weight of all of these batteries. This is, geez, probably 1,200 pounds in batteries. But there it is. We have equal length 2-gauge cable coming from each set of 24-volt batteries. So this is, you know, the way these are wired, that's basically one 24-volt battery. That's one 24-volt battery. These are each one 24-volt battery. When you series them together, the two become one, you know. So there is 6 equal length sets of red and black cable going into the new bus bars. Look a little bit better. Yeah, there's a lot of stuff going to it, and I had to kind of trim the shield a little bit to fit everything, but it fits. It's all there. So now battery capacity is back up to what it is supposed to be. Now every single 24-volt leg is going to get an even charge, and any load that is drawn from either the inverter or the step down. We have DC loads in the house, so I have a 24-volt to 12-volt step down, and then those distribute the 12-volt through the house, phone chargers, lights. We have some ceiling fans. My HVAC system runs on DC. A few other things, but these are the two components that draw from the batteries and then feed into the house. Whatever those are drawing, it's going to draw evenly from each set of 24-volt. It's all equal length now. I was going to make new cables going to and from the inverter. I've got some it's just a total mess down here after getting all this done. I've got some 00 gauge fine strand copper wire. That'll have to wait for another day. It is 00 gauge, but it's not fine stranded. It's real big strands. I don't know, well, that's not focusing, but you know, and the fine stranded stuff just carries the current a little easier. I've never had an issue. I've maxed this inverter out multiple times, never even gotten it to beep. I've never had a shortage of power. But whatever. Someday I will get to that and pretty that up a little bit. Because I made those a long time ago, and whatever, I didn't put shrink wrap on that one and that one, and I like everything to be pretty and uniform, so I will measure those out and make those equal length also. Get a fuse in there. Right now I've got the generator running. Actually, it should be warm enough to crank up. It's currently putting almost 1,000 watts into the batteries. There we go. There she's chucking some juice. I'll back her down to about 1,800. There we go. Almost exactly 1,800. Oh, yeah, just as I say something. Anyways. And now that these are all paired together correctly, with equal length wire, I want to balance them out, run an equalized charge on this. I'll run the generator until we get up to 30 volts, let it sit there for a bit, and then back it down to 500-600 watts, to where the volts settle down to 27.6, and we'll do a nice long float charge on it. I'll let it run itself out of gas, maintaining 27.6 volts, and that should balance everything out. And now that it's, you know, all hooked up correctly, I'm excited to see how much more life I get out of this. You know, if we don't have any wind or sun, we should be okay, you know, for 4 or 5 days, without making big power from outside, or having to start the generator. This time of year, the last month, it's been really gray. There has been very little wind. We had one real windy day, but other than that, you know, I've been having to run the generator a lot this last month, you know, every 2 or 3 days, and that's more use than I want to get out of it. I'm putting more hours on that engine than I want to. You know, it's backup. It's not supposed to be my daily power source, so I need to get my batteries happy again. Hopefully the improvements to the connections outside on the solar panels, we'll be able to get max power out of that. So the next time the sun comes out, I'll do a quick video and show them making max power. And if they don't, then it's a different issue. Perhaps, you know, my 60 amp charge controller can't actually carry 60 amps. I don't know, you know, or maybe I'm limited in my cable here, you know. This right here could be the culprit. So maybe I've got to make one more set of cables with this 2 gauge. Looks like that is probably 8 gauge. It's a very short length, but you know, that never had a problem getting the 1200 watts from the original 12 panels, but I'm frustrated with why I can't get max power. So this is the next thing I'm going to address. I might even do that tonight. If I've got more connectors, I'm gonna have to dig around in my bins and see if I can find 2 more ring connectors, but if I've got them, that's the next thing I'm addressing. Gauge that up so that can handle all 60 amps. You know, this thing should be able to carry 60 amps. That's what it's rated for, and I've only been able to see about 47 come out of it, which frustrates me. That wasn't cheap. So if that can't do what it's rated to do, that's what we're going to figure out here. And that's the whole purpose of this YouTube channel, so you don't go and spend money on something that can't do what it's rated to do. So far I've been very happy with it. It has done really well with the original 12 panels. Like I said, I saw over 1200 watts coming in multiple times. So 1250, I saw 1300 watts coming in from 12 100 watt panels. So now that there's 16 100 watt panels, I want to know what's going on. And this very well might be what's stopping all of that from coming in. So anyways, if you stuck through to the end, thank you for watching. I'm going to try not to trip on my mess while I back up so you can see everything, but take care. God bless you. Happy New Year's. Alright, I know I signed off. I needed to follow up with, well anyways, I made my new cables for charge controller. Now there's 2 gauge cables on that, so that absolutely can and will carry all 1600 watts from the solar panel. So if it doesn't now, it's the controller itself. Moving on, these batteries, in the location they were, in the wiring orientation, they were, let me see if I can find a cable. Cable that was on there I had made a long time ago. Excuse me. Overvolt. I opened up a couple caps to see, you know, if the batteries were bubbling, and as you can see, most of them behaving as they should. But these two especially are absolutely not. I gotta get them up to 31 volts to get them to start to bubble. Yeah, we just hit 31. And it's only taking 500 watts from the generator to get these guys up to 31 volts. So them sitting down there with this wire, which had completely rotted, and there must have been almost nothing going through that. I can't see how there could have been. Like, this is literally what came out of there. It just it crumbled apart. Like I said, I made this cable a long time ago. Geez, probably 5 or 6 years ago. This was out of I chopped up jumper cables. I forget what brand. I got them from Menards, but they were advertised as, you know, 2 gauge copper, super heavy duty jumper cables, and I was short on cash that day, so that was the cheapest way for me to make some battery cables. So for however long these batteries have been down there, they've been getting just the tiniest crap little trickle charge. So I've been almost 100% relying on these batteries, and these have been doing nothing but just sitting there degrading. So I actually disconnected the leads going to these guys. They're full, just sitting there full. And I'm just running the generator on these, trying to get the fluid moving around in the cells. And I have to keep my hand real close to the throttle on the generator, because it with literally 520 watts. If I turned it up to 600, it would go up to 32, and the overvolt alarm would kick on the inverter and shut the power to the house down, which actually makes a really bad snowball effect, because if that stops drawing, then those peak in voltage even faster. You can foam your batteries doing that, but right now I'm purposefully overcharging these and letting it go high to try and get that fluid moving, because that's the only way to restore these. So I'm basically gonna have to hang out down here for a while and just keep them at 31 volts and see if I can warm these plates up and break down the sulfur that must have developed on the plates. All the cells are full, which I haven't filled them in probably over a year, and that cable 100% explains it, because they haven't been being used. They haven't been being charged, and they haven't been drawn off of. They've just been sitting there degrading, and that's why none of this fluid has evaporated out. Every time you charge them, this is what they do. They bubble. They literally just boil, and that water slowly evaporates out of there, and you have to top it off. I gotta top these off 3-4 times a year. I check these guys at the same time that I check those, but they haven't gone down, so I haven't had to top them off. But I am concerned about these two batteries. If I can't get them back in shape, I'm almost better off removing them, pulling this one over here, and maybe I can just hook these up on a completely independent solar system. I've got extra panels and an extra charge controller laying around, and just have that, let that trickle charge, and slowly rehab. Every day it'll put a little bit of power to it, and it'll slowly bring the battery back. I don't want to be short 2 batteries, but this discovery, this is going to be huge when I bring these guys back. This 100% explains why I'm having capacity issues. I've been 100% relying on these batteries. Nothing was getting through that cable. They weren't being charged, and they weren't being drawn off of. So I've been completely drawing off of just these, which is not enough. It's not enough capacity for my usage. That explains why I've been having to run the generator more often, because that cable. I don't know how long that's been like that, but there wasn't no power getting through that. So so yeah, that's the status of this. I'm gonna let this go. Oh yeah, look at that. It's starting to go. Oh, that is just fantastic. I'm not ready to give up on him yet. I got a lot of time into this project here today, and I got a lot of money in these batteries. That really it pisses me off, because I preach, you know, don't cheap out on wire. And that's why you don't cheap out on wire. Keep an eye on your connections. They can corrode. The sulfuric acid can seep into these. You can see it on this guy. This is the same terminal as that. You know, I'm gonna take this apart, clean this guy up. I'll peel my shrink wrap off of there, make sure my wire is still good. A lot of times when I'm doing equalized charges, I'll pull all these caps open and just let them bubble. You can see there's a little moisture on top of the batteries. Well, that will slowly eat away at your connectors if they don't have a coating to protect against that. So I'm gonna have to clean that guy up, and you know, you gotta keep an eye on stuff. Don't cheap out on your wire, because that's, your system is only as good as its weakest link. That was my weakest link today, and I found it. I would never have found it had I not dug into the system like I did today. I did major surgery today. So I'm not gonna drag this video out too long, or any longer, but yeah, this is what can happen if you know, I try to do good maintenance, and you get a little wrapped up, too busy with other projects, and overlook something so stupid, and I may have destroyed 2 batteries here. And this whole block, the capacity is so pathetically low right now, with only 500 watts going in, 140 coming out, so 350 watts going in, and they're just sitting here at 31 volts. So I'm gonna have to boil these guys for a long time to try and bring them back. But I'm glad I figured it out. They're not done yet. I'm not done with them. I'm gonna save them. So once again, thanks for watching. God bless you. Take care. Don't cheap out on your wire. Don't be stupid like me.